So last time we discussed map, filter, and list comprehension, right? So one more thing about that. Let's say I have a list which contains 10, 20, 30, one take a list. What I want is I'm writing the list comprehension to do a square of 10 million numbers. So I'm saying value into value for value in range. Let's say 1 to 10, 6, 0, 1, 2, 3, 4, 5, 6, 1 million. Let's make it 10 million. Okay. And so this is the list comprehension for me. What I want to check the performance. Okay. So this is one approach for my list comprehension. Second is my map, right? So I'll say let's say map object is equals to map of again define the same range, that is the range of okay. Tell me the lambda. Uh-huh. 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 Okay. So this is my map and my normal for loop. Here it should be range of 1, 2, 3. Okay. So this is the lambda and this is the range. So for in range, let's take the same example. Okay. I'm taking one list and here I will just say, so here I'm not checking performance to print the value. I'm just checking how much time it actually takes to calculate this. Okay. Value star. Okay. So these are three expressions. So different approaches, right? To check the performance, we have this library called time. Okay. So all you have to do, the statement for which you want to check the performance, we just need to add it to the function, that is timeit dot timeit. Okay. You need to specify the statement. Okay, for this particular statement, I want to check the performance. Okay. So if you have multiple lines, you can specify as you are specifying the triple quotes. So this will not throw any error.
Usually when we run code, right, then it says
yeah, but that's not so that's actually entire time taken to execute the entire program, right? Okay, I'm taking this. Now using this, I can specify the number of iterations also. That same statements, how many times you want to run. Okay, but for now, I'm just keeping this thing to 1. Okay, execute this only one time. Okay, so I'm commenting this out. So it will just print the answer directly. What happened? Brackets are wrong. Yeah. This will tell me a time. Okay, so it's taking 2.60 seconds. Okay, for this much large change. Okay, seconds. Oh. So this is okay, right?
No matter. Yeah.
Okay. So it's actually taking 2.60 to complete to execute this particular statement of this range, right? Same experiment with t equals to time it dot time it. Is everything correct? So statement right. Okay. So your map is taking 3.29 seconds, and this is something different. That day I tried the same experiment. My map took 0.6 seconds to do it. Okay. Now this is 5 seconds. Oh, exactly.
You put it to the right hand side. Extreme right.
Yes, I'm specifying using the radius statement. Map lambda range. Oh, we haven't noticed this. So it's e raised to power minus 6. Okay. So it's far less than 0.7 actually. Okay. So yeah, performance of map is comparatively very fast as compared to your this comprehension also. And if I do the same thing with normal for loop, e is equals to time it dot time it. Let's say statement equals to this triple quotes, comma, number equals to 1. Okay. And print the G. Okay. Execute this now. Okay, it took 4 seconds. If I try to execute it again. Okay, so performance, so this is around 4 seconds. This is around 2 seconds, and this is something very small. Okay, so it's e raised to power minus 3. Okay, okay.
Install anything like
No. It's a default.
and no, can we print this and
Okay.
what is this one?
Yeah, so that will be, so that day when I conducted the same thing. Okay, so normal map actually took 0.6 seconds. Okay. I typecasted to the list and printed the list. For typecasting operation, it took 7 seconds. Okay. Yeah. It just convert to just it was actually not print operation. It was just a typecasting operation. Instead of typing, I just used the instead of map directly use typecasting. Performance went to 7 seconds. For this. Okay. That day for my list comprehension, it was around 3 seconds, 3 point something. Maybe my system is getting slow, you know. And for normal for loop, it was something around 6.5 seconds. Okay.
It is more than 10 million it's giving memory error.
Memory?
Yeah, memory limit. And then error like module of it is not correct.
Sure. Is everyone please try? Just type import timeout and try to run. If there's error in module, then yes, then we try for import.
No.
Now, no error. Okay, then the library is working fine. Try help of timeout.
I'm just saying you did it wrong syntax.
Because if import is working, then there's no issue with library. It's getting imported successfully.
Every time you have it shows a different.
Yeah. So it's completely depend on the CPU cycle and the utilization. But still, you can calculate the average performance based on this. Try it 5 times and take one average. This will give you the good picture. Okay. Keep in mind, if you are not specifying this number attribute, defaultly it will execute this particular statement 10,000 times. Okay. So you can check it here. If I do help of time it dot time it. It's not a 10,000, it's actually more than 10,000. And it is actually 1, 2, 3, 4, 5, 6, so it's 1 million times. Okay. So by mistake, if we just specify the range of 10 million, so the same statement of 10 million, it will try to execute on 1 million times. And then it will show that how much time it will take.
You know what was the issue?
Mm-hmm.
So I named that file itself Itertools. So it was
obviously it was taking that model, not the help of that is nothing.
I renamed it and removed that file then again.
Yeah. What do you want me to? Here, instead of number, you want to take a square.
No. Sorry.
Typecast it. Alright.
Square.
You want to print the result. Yeah. Alright. So just take the brackets. 1, 2, 3 opening, 3 closing. Okay, perfect. So I'll get everything in here. And after this statement, I will say print m. Okay. So entire program you can write here. It's just if you want to check performance of entire function, write your entire function in this time. Okay. So, do we have anything else? So, okay. I'm trying to print that much numbers.
It will print also
I added print statement also.
at the last. No?
Yeah. I typecasted it
Okay.
and then I printed it now. Now printing operation is easy.
Five minutes.
Don't cause me overflow at least. If it's not causing overflow, then that's great of Python. The overflow work or still showing overflow?
No, yeah, I
It's
added
clear.
more one zero.
Okay.
Under here.
Oh. Oh.
So add one more zero in the
Uh-huh.
range.
Uh-huh.
Will give memory.
Acha.
Okay.
It's too much.
Before time you write 400 million.
Acha. Further doing it PySpark then. It's not PySpark, NumPy will also do.
Okay. So 16 seconds for 100 million.
16 seconds, 100 million.
For list comprehension, that is 6.64 then E
C raised to
minus and the map this map list comprehension took more time. Otherwise, this map
I know what you asked me to do.
here at 6 million.
It's look like now that printing thing is also tired printing one. Let's check the CPU utilization. So I was taking 500 MB memory. And do we have any separate for Python?
How many pages is printing? More than millions.
Yeah, because it's a square.
Yeah. Oh. Listing out. Yeah. It will take ages.
23% 400. I guess we need to terminate this. It's not enough.
So only way is to
And the only way is make some error.
error and then run.
Run. No, I don't want to run it now. Okay, we check now. It's now it will come to into seconds. 4.39. So this is your timeit library, and this is your performance of your map, lambda, and null for. So let's start with generators. So generators are used whenever you need a lazy evaluation. Okay. The same thing that we did now, that printing 10 million numbers by mistake. Okay. If we need such computation that we are working on a large number, okay, we will never use such large set at a time, right? If we need it also, we will ask for one number and or 5 numbers or 10 numbers and work on that. Okay. So similar approach, you can similar number set of numbers you can get using generator. Okay, so generators is just a small modification into your functions. Okay, so let's take example that I want to generate a Fibonacci series. Okay, now I want to generate a Fibonacci series which will be infinite. Okay, it's just whenever I request a number, it should give me fetch one number from that particular list. Okay, so first thing you have to write the function. Okay, if I give call to this Fibo function, right? Normal logic, I'm saying first number is equal to 0, second number is equals to 1. Okay, I'm saying while true. So this is an infinite loop, and this infinite loop I'm saying next number is equals to first number plus second number. Okay, after this I should write, after adding, my first number and second number should change. My first number should become second number and second number should be next number. Okay, now my output is next number. Okay, in case of your normal function, you'll create a list and you'll try to append it here or you'll print it here. Okay, I'm doing only one thing. I'm saying something yield next number. Okay, so instead of writing return statement or instead of writing print statement or appending to a list, I'm saying something called yield. Okay, now when I give a call to this particular function, that is Fibo. Okay, if I just print this G, I will not get the answer of this particular function. What I will get? I will get the generator object. Okay, so what is concept of generator? That whenever there is a function call, okay, and if there is, and that function is a generator, okay, it will not go and it will not execute your entire function. Okay, at this time, it will just give you one object to execute this function. Okay, that's it. Now, if the function call is normal function call, how it works? That it will go to the top, search for the function definition, execute entirely, and return the result. Right? In case of normal function, it will not maintain any particular state. That let's say I want to get numbers from 1 to 5 here. Okay. Next time I want numbers from 5 to 10, and next time I want from 15 to 20. Okay. If I try to do this with my normal function call, it will not maintain the state of variables. If from each time whenever there is a function call, it will initialize your first number to 0, second number to 1, and calculate the result. Right. On the other hand, the generators are mainly known that it will maintain the state of your variables and they will maintain the state of your functions.
All the variables.
Yes. Yes. Okay. So now when I say G is equals to Fibo, it given me generator object. Okay. So how to get result of this? So we have a function called next. Okay, I'm saying next of this generator object. Now if I execute this, I got 1. Execute it again, I got 2. Okay, so how this works? Okay, so whenever there is a function called to this next with this generator object, okay, at this time it will start the execution of your actual function. Okay, so whenever there is a first next call, okay, it will start from here and it will execute till yield statement. Okay, it will execute till yield statement. Okay, now next time when there is again a next call, okay, it will start from this yield statement till it encounters the next yield statement. Okay. So now if you see, I'm saying next number. So this has given me 1. Okay. It will stop here, right? Whenever there is a next call, it will execute the statements. That means it will swap this first number and second number. As I said, it will maintain the state. Okay. So your count of first number and second number is maintained, even though you come out of the function. Okay. So now your first number is second number is next number. It will swap it. It will calculate the next number and it will encounter the yield again. Okay. So yield is my output. So it will give the output and it will stop here only. Okay. Whenever there is again yield call, next call, execute this statement, throw the output, stop here. Next time, execute this, and stop here. Okay. So now let's see how you can use this. Okay. So next, whenever I say next, it is giving me one number, right? So how about I want 5 numbers at a time. Okay. So I'm just saying for value in range, or let's say I want 3 numbers or 2 numbers. Okay. 1 to 3. I'll say print next of G. Okay. This has given me number 1 and 2. Next time I want next 10 numbers. Change the range. Okay. I'm saying 1 to 11. Now, this will not give me the numbers starting again from 1. It will continue from there. Okay, so it will give me 1, 3, 3, 5. Okay. Now Fibonacci series generally start from 1, then 1 again, right? Here if you see in the output, as per my logic, it is supposed to give something like this only, right? So I need that extra 1. So there is no limit on how many times you can yield the element. Okay. So here I will just say okay, I can write multiple yield statements. Okay. In case of return, I can write only one return statement. But in case of a yield, I can write n number of yield statements. Okay. So how it works? It will work from yield to yield. Okay. So whenever there is a first next call, it will start from here, execute this, execute this, execute this. Now this is a yield. Give this output and stop here. Okay. Whenever there is a next function call, then it will go into this while loop. Okay. Now this is an infinite loop, so now it will not come back to here. It will be playing around in this around this 3 statements. Okay. So now if I execute this, now I'm getting 1, 1, 2, 3, 5, something like this. Okay. So it's like now whenever I need numbers, be it one number or be it 5 set of 5 number or set of 10 numbers, I can get it using generator. Okay. I said the execution will be from yield to yield. Okay. So Okay. In the same program, try adding another yield and try to get what exactly you're getting the output. Okay. So just write yield next num again here 2 times. Okay. And tell me the difference. Okay. So for now, just change the range to here 1 to 3 and then 1 to 5. So here instead of one yield, try same yield again. Copy paste the same statement again. Yeah, 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 in the same line. Write one more yield here. Okay. If I do this, I will get output something like this. Can anyone explain?
Same number is printing 2 times.
Mm-hmm.
In first number is 1 because when you get
That okay. Second now. Okay.
otherwise all are repeating because
Repeating.
P into E.
Exactly. Okay. So your execution will be again from yield to yield. Okay. You can write n number of yield, but if you write next yield here, so initially it will calculate one. Then I'm again adding some yield. Okay. That's why it will again give the same number and it will stop here. Now next time when I give a call to this next function, now it will calculate the first number, second number, and then it will go up and it will give me the next number. Again next time this yield statement, so I'll get the same. Okay. So there is no limit on how many numbers you can provide as output from your generator function. Okay. Last important concept about generators. is if I have a list, I'm writing one function. It will take a list as an input, okay, and it will just print the element of this list using generators. Okay, so I'm writing for and L, okay, and I'm saying yield value. Okay, again, if I say G is equals to print val, I will get the generator object while passing I'm saying 10, 20, 30, 40, and 50. Okay, all right. So have a look here. When I say next of G, I'll get 10. 1, 2, 3, 4, 5. Okay. Yeah. That's okay. So I added 5. Okay, and there are 5 elements. Okay, I am adding one more next now. Okay, so this will throw me a stop iteration exception. Okay.
Shouldn't you go out of the loop and
No. So the thing is, if you use generator object, okay. So whenever this object is iterable object, okay. So whenever I use something like this for value in G, okay, and if I say print the value, okay, now it will give me only 5 values, right? Okay, because I'm iterating over the object, okay. But if I'm using this next object and if I specify it the greater than the exact range, because in the first example we were generating infinite number of numbers, right? So that's why no matter how many times we give a next call, it will not throw this exception, okay. But if I'm taking a small list, okay, and if I specify the next more than the element, it will throw the exception that is stop iteration. Now this is the same exception is thrown whenever you use your normal for loop also. Okay. So internally, whenever you execute your for loop, internally your Python throws stop iteration exception, and this particular exception is handled internally so that it gives you the feeling that okay, it started from the first and it ended at the last. Okay. So same thing when we cover exception handling, we will be handling the same exception. Okay.
what if we return some value from that function?
No,
It will come out of that.
no, yeah. So you can combine that, no issue. Okay. So I'm saying yield value and then return value. Okay. Now I'm doubtful because at the same time I'm accepting this yield also and the generator also. But let's give it a try. Okay. So the thing is, I've executed yield first. Okay. How about it? So if it's yield, right? So it will come out here. What I'll do, I'll add this here. The thing is, if I add return now, it will execute return.
If you print,
See, so even if I add a return statement, it is giving me something as a generator only because I have a yield, but that's fine. What is the answer then? Hmm, let's try next. Now it will give me error.
stop iteration.
Okay. So there is a return statement here. So by this approach, you can convert a normal any function, just replace your return with yield, and this will be a generator function. Okay. Now, how about such lazy evaluation in case of your list comprehension also? Okay. So we discussed list comprehension, we discussed map. Okay. So your list comprehension also was giving you the entire list, right? So if I have a list 10, 20, 30, 40, 50, I want square of each number. I'll say for value into value 54 value in L. Okay. Let's make it L2 and print. Okay. So this will give me the entire list. So no matter how big my list is, it will each time calculate all the elements, right? Just convert it to tuple. Okay. So if we replace the brackets, this is not actually tuple. This is called as a generator expression. Okay. So now let's print your this. You can see now you're getting a generator expression. How to print the values? Again, print next of L2. Okay. So such lazy evaluation you can get in case of your comprehension also, using the generator expression.
Only with tuples.
It's not a tuple actually. See, the thing is, whenever you are doing comprehension, right, just try to understand. So this is your append operation, which means you are modifying the list, right? But if it's a tuple, this is my immutable data type, right? So I cannot have comprehension for that. It's just now you can say it's a syntax of a generator expression. It's not a tuple. It's not a tuple. Okay. Want more practice of your comprehension? So, try this example. Matrix addition. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 100, 200, 300, 400, 500, 600, okay. 700, 800, 900. Okay. I have something like this. I have two matrices and I want to add individual elements. How it works? So I need to add this 1 with 100, 2 with 200, 3 with 300, 4 with 400, 5 with 500, 6 with 600. Likewise. Okay. Just to give you the hint, if you find out the indexes, so here I have 0, 0 for 1. Okay. Here also I have 0, 0 for this second matrix. So let's say this is M1 and this is your M2. Okay. Next time you want 0, 1. Okay. Here also it will be 0, 1. Okay. And this will be 0, 2. Right. If I find out that this element, it will be it's a matrix, so that will be list in list. So 0, 0 is this, 0, 1 is 2, 0, 2 is 3. If I say 4, what will be the index of 4? It will be 1, 0. Okay. So if you look carefully, that for the first thing, so this is the number of rows I'm having 0, 1, and 2. Okay, and this is the number of columns I'm having. Okay, so you need to find out a logic using which you will fetch this rows and column and you will get the matrix addition. Okay, using your list comprehension. Okay, try this. I'm saying L1 is equals to, it should be less than list, so 1, 2, 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9. Alright, this is one list. Take another as 100, 200, 300, okay, 400, 500, 600, 700, 800. Okay. Need logic is here. Okay, the main logic is you need to find out total number of rows and total number of columns. Okay. Alright. First try with normal for loops. Okay. So I'm writing. Tell me the logic if I want to do the same thing with a normal for loop.
Two for
One
is the range of 0 to length of L1,
So for value in range
0
uh-huh,
length of L1,
to length of L1, that is your total number of rows exactly. Okay.
or
Or let's say value 1 in
length of L1 of 0.
okay, length of L1 of 0. Why? Because second should be the number of columns, right? Okay, next. Should I take another list? Let's say LC is equals to blank list. So L1 of value and value 1 okay, plus
L2 of value.
okay, so here I got the addition. Then
Then we will 3.
okay, keep in mind if you directly append the sum exactly, so you are flattening it. Yes, yes.
We have to make actually 2 lists. So the first, let's say L4 as well.
Where should I define it here?
Yeah. I mean, we can define inside actually. So just between the two for loop.
Okay.
Yeah.
L4 equals
empty
blank.
And then keep on appending. And at the end of first for loop, append it. Then,
okay, so now I'm saying L4 dot append sum. Okay. And
outside of the first for loop.
Here I will say L3 dot append L4, right? Tool append L4. Okay. So what is the logic? So you need to traverse for number of rows first. Okay. Now if you see why I'm traversing by the number of rows. Okay? So here if you see the sequence that here I'm getting 0, this 0, this 0. So 0 is constant. Okay. So for first matrix I'll get 0 comma 1, 0 comma sorry 0 comma 0, 0 comma 1, 0 comma 2. Right. So your first 0 is constant. Okay. Second time if you look, it will be 1 comma 0, 2 comma 1, my bad. 1 comma 0, 1 comma 1, 1 comma 2. Next time it will be 2 comma 0, 2 comma 1, 2 comma 2. So your first thing is constant. Okay. Now for the entire row. So you need numbers which will give me from 0 to 3. Okay. So that's why I'm taking here length of L1. Okay. Now I need a matrix. I need these two iterations. Okay. So this is my number of rows and this will give me the column index. Okay. So outer for loop is I'm taking number of columns, that is length of L1 of 0. Okay. Now either you can go with L1 or L2, but the condition for the matrix addition is that both matrix should have same dimension, right? So here I can say length of L1, L2 here, or I can say length of L2 of 0. That is also fine. Okay. As output, I want list in list. Okay. That's why here there is one separate list. So we will keep on adding the element to this list. Okay. So it will store the addition, that is 101, then 202 and 303, and this entire list as a result I want to add it into this list. Okay. So whenever I get answer, I'm saying L4 dot append and add the answer. Okay. Now this list contains 100, 200 and 300. Okay. But this entire list I want to add as output to another list. Okay. So that's why I'm here saying L3 dot append L4. Okay. Now if you are able to do this with for loop, you can easily convert it to the comprehension. So we don't need this append operations there, right? So this will be your output that I want addition of this two. Now only thing is you need to make sure that you get this value and value one correct. So the concept is I can convert every for loop into comprehension, right? So if I want to convert this for loop into comprehension, all I need to do is I need to just copy paste the correct statement from this. Okay. So let's say this is L3 is my answer. Okay. So ultimately answer which you are expecting is this. So I'm copying this. Okay. But we want list and list, right? If I add it like this, I will get only normal flattened list. So obviously I want a list to list, I'm adding one more list here. Correct. So two opening. Okay. So this is the list and list. So I need one for number of rows. What is that for loop? So this is the one which will give me for number of rows. So I'm pasting it here. Okay. Where should I paste this one?
Inside.
Mhm. Okay. And the file. Okay. So let's make it simpler. So this is the ultimate answer, and this is your first test comprehension. Okay. So as you have seen in this example, I need two for loops. In comprehensions also I need the same, right? So now this will give me the number of, so this will give me the count of row, right? So it will iterate from 0 to 3. Okay. It will get one element from this. Now I need columns, but columns should be repeated. Okay. So this should also, I get this multiple times. And that is the reason I'm putting this inside. Okay. So if you are able to write a logic using normal for loops, all you have to do is copy paste the correct statements in correct order, and this will be a comprehension.
Then you can change it to generator.
It will give one element at one list at a time. Because this is one element, right? Remember perfect number?
Some of it is
So write a list comprehension which will generate all the perfect numbers from range 1 to 100. Okay. Now what is perfect number? If I get any particular number, I need to find out all the divisors, that is 1, 2 and 3, for which I need to iterate from 1 to 5, and I need to do addition of all the divisors. Okay. If that is equal to the number itself, okay, then I can say this is the perfect number. Okay. But logically, this you can make it tell. Okay. So consider any number. If you go till half only, that is half of that particular number, let's say 64. What is the smallest divisor of this? That will be 32 only. You will not get any divisors after 32. Okay. So just you have to make sure that you iterate from 1 to 32 plus 1 so that you will get this 32. Try with filter, that will be better actually. Okay, so you need to specify one range, that is 1 to 100. Pick one element, pass it to the function defined in the filter. Okay, and this will return true if the function is a perfect number, else it will return false. And the filter will automatically pick the element for which answer is true. Okay. Since your logic will be multiple lines, it's not advisable to go with lambda in this case. defining one function called perfect number. Okay, and here I'm giving a range that is from, let's say, 1 to 101. Okay, we will pass one element at a time to this particular perfect number function. Okay, and obviously this will return me the filter object. Let's typecast it to the list and get the result. Now, the definition perfect number. Okay, so this filter function, what it will do, it will pick one element from this range, pass it to this perfect number function as a input. Okay, so now you have one element here. Okay, so what you have to check, you have to start from one and go to this particular number, right? So, but we have seen that we don't actually need to go to the entire number. So if I say for value in range, I will say 1 comma number. Let's make the range smaller, floor. Okay, so I'll see this, and I guess I will need something from this point. Okay. Here I'm saying if num mod value equals 0. That means whatever number is, let's say we are checking if 6 is perfect number or not. If someone gives you 6, I will start dividing it from 1 to 3. Right? I guess we need to specify +1 here. Okay, alright. +1. Okay. I will check if that number is divisible by. If this is divisible by, then only I'll make effort to do the addition. I'll say sum is equals to sum plus value. Okay. After this, I will check if sum is equal to the number. If this is the condition, I will say return true. Why is it showing this return in a red? Bracket is not range. Right? Range. The return true, otherwise false. Okay. So how filter works? So it will check for the answer. If your answer is true, then only it will give me the number, right? So let's print this out now. Oh, we have only two perfect numbers. All right, 200. No, only two. That's the first time. That's what it is. Okay. All right. move ahead. So next thing we'll discuss is called okay. So there's nothing new in Itertools. Whatever things we have done, we will be just optimizing the same things. Okay. So what is Itertools? So Itertools are used mainly for your efficient looping. Okay. So it will give you a lot of functions which will simplify your looping statements. Okay. So how? Let's start with chain. Okay. Now you have multiple lists. Okay. Something like this. Now I want to iterate from this list 1. After that I want to iterate through list L2. And after that I want to iterate over L3. Okay. So for iteration I need a single list, right? So for that, if I go with a normal list operation, I need to write L1 dot extend L2, then L1 dot extend L3, right? Let's say now I have 10 lists. I'll keep on writing this extend statement, right? But I don't want actually a single list. I'm just interested in iterating over this list, right? Now this list can be anything. Let's say you are reading 3 to 4 files using your read lines function, and you are getting your entire file content as a list element. Okay. Or let's say you are making some query on your database. Okay. And this is the result from your table 1. This is the result of your table 2, and this is the result from your table 3. Right. You want to iterate over the result of multiple tables. Okay. So in such cases, you can use your chain function. So I just say for value in here. I'll just say Itertools dot chain, and I can specify n number of elements here. Okay. So now if I print the value, okay, it will iterate first list, then second list, and then third list. Okay. I guess we have already seen the zip function. Okay, so zip was earlier part of Itertools library. Okay, so what zip will give you? So you can iterate over multiple lists simultaneously. Okay, so now you are getting first element of all the 3 lists. So if you want to make some comparison on this, you have all the 3 values with you.
But for zip, the number should be
same, otherwise it will ignore.
For chain, it doesn't matter.
It doesn't matter. It's adding this at the end.
It doesn't give error, but it misses both.
Zip, yeah. Okay. Now for your entire Itertools library, it is not mandatory that this should be a range only. Sorry, this should be a list only. Okay. This is not a restriction. So here I'm taking an example of a list, but I can use a tuple here. Okay. So I'll say tuple of 200, 500, 600. I can create a range also. Okay, whichever iterable data type, so it can be result of your map also. So create a map, assign it to any variable, and add it to the chain, and it will iterate. Okay, so be it anything, all you have to do is chain of L1, L2, L3, L4, L5. So next function is count. So we have seen range function. So while range, when it specifies 5, what is this? So this is the end, right? Whenever I say range 5 to 50, I need to specify the end. Here also I'm specifying one end. Okay. So for the range, it is mandatory for me to specify the end, right? But now I want a number series. Okay, I'm doing some scientific calculation, and I don't know the upper limit. Okay, I want the numbers infinitely. Okay, so for that I can use this count method. So what this count will do, for value in Itertools dot count. Okay, so it will defaultly start from 0 and it will give infinite numbers. Okay, now it's your responsibility that how you will accept, how will you make the break condition. Okay, so if I say if value is greater than, let's say, 20, then I'm saying break. Okay. Okay, so now it will start from 0 without any upper bound. Okay, I can specify the start, so I can say start from 10, and let's modify my condition to 50. Okay, so now it will start from 10. Okay, to 50. I can specify the increment. Okay, so now I get 10, 15, 20, 25. But the only thing is I cannot specify the end. Okay, so I can specify a start, increment, but not the end. So count will defaultly start from the range which you are given to infinite series. Okay, you have to handle the break condition. Okay, and if you have a list of 100, let's say 200, 100, 200. So we have one islice function. Okay, so this is a slice, which means if I have this entire list, it will give me the some portion of this particular list of this. Okay, as per the name. So I need to tell from which list exactly I'm supposed to get the slice. Okay. So I slice L. If I say something like 2, okay. So now it will start from 0, 1 and 2. Again, this is your end index. This is not the value, this is the index. Okay. And this is again not inclusive. I can specify the start from 2, go till 5. 0, 1, 2, start from 2, 3, 4 and 5. 5 is not inclusive, so it will give me 300, 400, 500.
Can we dictionary
Yeah, but the thing is, I cannot use my indexing here, right? So ideally it should not work, but let's
it will give
try. I don't think so, because here whatever I'm specifying, okay, these are my indexes, right? Even if I do help, let's say they have provision for keys or not. So help of Itertools dot stop, start, and step. Return cited is next. Skip all elements. Step is package documents. Slice and the list items and etc. They haven't mentioned anything. Let's give it a try. So 1, 10 to 20 and 2, 30 colon 5. Okay. And slice B. Let's make it 1, 2, 3 for now. So it's showing something. Yeah, it's showing key. 0, 1, 2. Yeah, it's showing keys.
zero.
This is the thing, because I cannot guarantee that this is the first element. Right? In case of a dictionary, I don't have indexing. Internally, even if I'm storing this, so it's not mandatory that it will store in the same way. Okay? So we have to check this with large dictionary that even, because it may happen that for the same thing it shows different results. It may happen in case of dictionary.
Same thing with set, right?
Set, yeah. I guess set should display the output of the data. So 2, 5, 10, 25, 35. Okay. So now you cannot get the
Repeat random
anything.
Can you run it again? It should go different.
No, no.
Internal memory ones.
No, it's not actually random. It is running a hash function on this particular key. Okay. Now after running hash function, whatever value it will get, that will be the index. Okay, so it's that it is using indexing, but which is internal. You cannot see that indexing part. All right. So next function, if we have a normal list, and if I try to add it to the normal for loop, it starts from this and it stops here, right? I want continuation. Okay. If this is the end, start from the first and continue. If you reach end, start from the one again. Okay. Okay. Again, this Itertools.cycle, it will keep on infinitely cycling over this list. Okay. So you have to make sure that you stop at particular point. So here I'm saying count is equals to 1. Here increments the count is equals to 1. If count is greater than 20, then okay. So if I execute, yes, it will give 10, 20, 30, 40, 50. Again, once it reaches the end, it will again start from 10, 20, 30, 40, 50, 10, 20, 50. Okay? It will keep on doing the same thing infinitely. You have to specify the explicit break condition. Okay? If I just change this cycle to repeat. What is the difference?
20, 20, 20.
Mhm. Okay. So what this cycle will do, it will keep on iterating over the elements. The cycle, it will iterate over P, Y, T, H, O, and separately. Okay. Once it reaches the end, it will start again. On the other hand, repeat, it will give the entire string or a list or whatever thing you will specify here repetitively, and that will be infinite times. Okay. Again, you have to handle it using your break condition. Okay. If you want to iterate over one list multiple times, right? Considering it as a separate list, okay, you can use this method that is called Itertools dot t, and to specify the list here. And what this is going to use. Okay. So what this method is, so T, it will give the multiple iterable objects. Okay. So defaultly, if I say T, it will give me two objects. Okay, for iterating over the same list. So even if I now say for value in T of 0, okay, I get the same result. Or okay, but I getting only 50. So something Itertools T object. Okay, this is another object. Oh, so it's look like, yeah. So if I say and no, no, it's repeating the 50 again. So the last number is there, right? So it's just keeping the count of that. Right? So
He's giving the separate thing again, same list.
same list again. Uh, okay, so let's try it again then. Something for value in T of 0, and then I'm saying for value in T of 1.
Okay, you are printing value.
Oh, okay. So I can create, so if we just specify a number here, 5, okay, it will create 5 objects for you to iterate over this list.
By default.
Yeah, by default it's true. So for count, repeat, cycle, G, mm, something else. Last two functions. Connotations. So what are the different ways of selecting two elements from this three elements? Okay, and we are using this permutation. Okay, where your 1, 2 and 2, 1 are separate elements. Okay, so if your order is not important, I can go with combinations. Okay. So now it will not show me 1, 2 and 2, 1 as a separate result. Okay, it just keep count of numbers. Okay, So these are the some of the important functions from this Itertools library. You can explore it more because there are a lot of functions in this library. Okay, but these are some of the most important ones. Okay. So for optimization things, we have